Here, wider support beams are employed to permit still more movement, able to withstand a displacement of up to 20 feet sideways and 5 feet vertically. In the area 75 miles north of the terminal point at Valdez, the Tanana and the adjacent floodplain area, the pipe is laid across 300 feet of river bottom and 1,600 feet of floodplain. Side booms, working in concert, position the line in ditches 15 to 18 feet deep. Then it is anchored by 9-ton concrete saddles every 5 feet. The criteria for all floodplain crossings, either aerial or submerged, is derived from the maximum probable flood conditions which may be projected for each area, along with the resultant scour effects. The design magnitude is such that all sections will withstand even the severest weather onslaught. 3 small sections, totaling 4 miles, are literally frozen into the ground using a special burial technique. This pipe is coated with a foam insulation. The unstable permafrost is stabilized in a frozen condition. Refrigerated brine is pumped through tubes buried beneath the pipeline to keep the ground frozen. This type of insulated pipe is also being used in transition sections between above ground and below ground installations. Here, above ground sections are insulated by fiberglass, covered with a galvanized steel jacket between the supports. This will keep the oil warm enough to maintain maximum production flow rates and at the same time keep the pipe steel above minimum design temperatures. To complete this insulation, molded fiberglass and polyurethane foam modules will be fitted around assemblies and valves. As an added protection, thermal radiators are installed atop approximately 40,000 vertical support members. A pipe inside the VSMs will draw heat from the ground, which will be transferred to the thermal radiators and dissipated into the atmosphere. The soil remains frozen, thereby protecting the permafrost and other environmental features. Throughout the 800-mile system, no rule of thumb exists in river and floodplain design. There are 38 elevated and 85 buried crossings. Bridges requiring steel box girders, such as the Yukon River Bridge, modular girders, and cable suspension structures. The Tanana River, a 400-mile tributary of the Yukon, features the longest clear-span aerial pipeline crossing, a few miles south of Fairbanks. The multi-million-dollar structure with twin 170-foot-high towers supports 1,200 feet of the pipeline in an area marked by extremes. Winds recorded as high as 100 miles per hour. Temperatures ranging from 70 degrees below zero to 100 degrees above. River conditions that vary from swift currents to ice 5 feet thick. And seismic shocks of 7.5 recorded on the Richter scale. The Tanana River Bridge, a critical link in the pipeline system. This is Pump Station 1, the first of a series of 12 pump stations that will move the oil down the line. The pump stations, covering an area of 25 acres, are permanent self-contained installations. Each pump is powered with a jet engine and turbine-powered recovery unit. North of the Brooks Range, stations 1 through 4 are powered by natural gas. The rest of the stations will receive their energy supply from the pipe itself. On-site refineries are used to produce diesel fuel from pipeline oil. Most of the stations are built on stable soils in a relatively conventional manner. 5, however, are erected on refrigerated permafrost. Freezer coils are buried in the gravel beneath a plastic foam insulation mat to keep the soils frozen and stable. The terminal facility at Valdez is built on bedrock at a height well above a statistically probable tidal wave. The year-round ice-free port ranks as the largest crude oil loading terminal in the United States and one of the best equipped, safest, and most modern in the world. Each of those tanks is 250 feet in diameter, 62 feet high, holding 510,000 barrels of oil each. The facility has berthing room for 4 block-long tankers and a capability for loading between 80,000 and 110,000 barrels of oil an hour on the ships. Valdez, the 800th mile of the pipeline, where fjords meet forest on Prince William Sound. In managing this monumental task, Alyeska has not overlooked a unique challenge and responsibility to preserve the natural beauty that is Alaska. This continuing preoccupation with pollution control, environment, and conservation has resulted in bypassing the northernmost stand of white spruce on this continent, circumventing nesting areas, wolf dens, and allowing time for archaeological diggings when a site cannot be avoided, and preserving animal movement zones, fish spawning streams, mineral licks, and river and stream crossings. Particular attention is being given to revegetation and erosion control. The ground surface along the entire length of the pipeline, as well as around pump stations, the terminal, and roads, is being protected against erosion. 4 different grass seed and fertilizer mixtures have been developed for use in different geographical areas. The seedings are being made to encourage natural vegetation to recover at an accelerated pace. The system is designed to shut down during seismic disturbances and is expected to withstand even the severest earthquake. If the pressure in the pipeline drops 1% or more, electronic sensors will detect the change, and technicians in Valdez can close down the entire system in 7 minutes. In fact, more valves per mile are installed on this line than on any other line like it in the world. Huge block valves and check valves will limit the size of any spill. These valves are so designed as to stop oil flow if there is any interruption, and will limit spills in the average sections to 13,000 barrels, or less than 0.5% of the line. The oil spill contingency plan, developed by Alyeska, is one of anticipation and reaction. Areas have been identified that could be affected, where the oil will flow, and how to contain the flow if a spill occurs. If there is an interruption, that section of the line is isolated, and the proper officials are informed of the condition. Repair and rehabilitation crews are mobilized to control, remove, and clean up the spill until the situation is satisfactorily resolved. Project engineers conduct mile-by-mile checks along the entire length of the road and pipeline corridor, investigating and verifying all work to ascertain performance and prevent error. Observing a basic engineering premise: conformity to design and specifications. But in the final analysis, it's a story of man and machinery. Workers called upon to function under the most extreme conditions, attaining a degree of excellence demanded by the profession's most exacting assignment in a setting of matchless beauty. Mount McKinley, the nation's crown jewel, standing aloof in the Alaska Range. The enchantment of a waterfall in the Chugach Mountains. Crevices 100 feet deep score an ageless symphony in the Brooks Range. And machines, like those who operate them, are specialists, withstanding the rigors of the world's most varied climate, sustaining the icy Arctic winds of the Alaska North Slope to build the Alaska Pipeline.